Okay, Assalamualaikum and hello. Okay, and may I remind you again, don't forget to check in your attendance. Okay, let me share the screen. So in this class, okay, I will show you the next part. Okay, so I will show you the next part is balanced Wye-Delta connection. Okay, if you check your textbook, okay. Okay, before this, okay, let me, okay. So previously you learned about the Y-Y connection. The next part will be the Wye-Delta connection. So let me show you this form. Okay, of course, first you need to know how to draw this. Okay, let me maximize this first. Okay, how to draw. Okay, so this is a Y, okay, Y-Delta connection. Sorry, my PC hang again. Okay, so Y-Delta connection. So how to draw this, of course. So you use the same concept. Okay, so this one. Okay, how to draw delta. So you have a triangle here. Okay, triangle here. Okay, make sure you know how to draw this. Okay, of course, this is A, B, C. Okay, maybe I draw it again. Wait. So triangle, triangle, and triangle. Make sure you know how to draw this because usually they ask you to draw in the examination. Okay, let me check this first. Okay. Okay, you already draw it. How to label it? Okay, label is also important. So remember this is N, V, A, N. Of course, at the top is A. This one is VBN. This one is VCN. Okay. So again, the line current. This one is IA, IB, IC. Okay. So next, you label it. Okay, of course, this is VAB. Okay, from A, this is B, this is C. Okay, VAB, this one is VBC, and then go down VCA. Okay, remember how to draw this. And then you have a Z, because this is balance, you just put Z. Okay, no need to put ZA, ZB, ZC because it is a balance. Okay, of course, this is A, this is B, this is C. Okay, because you have delta, okay, previously I said that for the star connection, you have a phase voltage and line voltage. You are different, but the current is the same. For the delta connection, is this different in the current, okay? For the voltage, okay, for the phase voltage and line voltage is the same, okay? But for current is different, okay? You have line current and phase current. So you have line current here. This one is IAB because it goes from A to B, and then IBC, and then ICA. So you have IAB, IBC, ICA. Okay, try to know how to label it properly. So of course, from this, okay, they usually give you the voltage, okay, the line voltage, okay. But for this case, maybe I just show you from the phase voltage, okay. So assume that the equation is the same. Okay, let me show you. Draw the circuit, calculate V line, V phase, V line, I phase, I line at load and source. Okay. So the first thing to do is find the V line, V phase at load, at source. So of course, remember the positive sequence VAN, VBN, VCN. So V phase angle 0 degree, V phase angle negative 120 degree, V phase angle positive 120 degree. So you get this voltage. Okay, the voltage at here. Okay, at the voltage source. Now we move on to the next part. Calculate the V line at source. Okay, source or load. Okay, because you can see here line of, sorry, it's hanging. Okay, you can see here the phase voltage here. This is VA, VBC, VCA at the source is same as the phase voltage, line voltage at the load. So VL at the source or VL and or VL and V phase at load. Okay, make sure you understand. Okay, you can see here V phase is different than the V source, and make sure you know that there will be no neutral wire because you cannot connect to anything. But for this case, okay, you can see here voltage here. Voltage at the source is different from the voltage at the line, but at the source part, okay, but at the load part, the voltage is the same. Okay, the line voltage and the phase voltage at the load is the same. Okay, because that is the delta characteristic. Okay. So how to calculate this? Of course, just use, because this is a balanced load, you can just use formula. Okay, you can use the VAB is equals to VAN minus VBN because of the Kirchhoff current law. Okay, but this one is for balance, unbalanced load. Unbalanced usually, okay, unbalanced also depend also. Okay, but I suggest you don't need to do this. Okay, this one is take longer time to calculate. You just use the general formula for this case. Okay, for this case only. Okay, try to know remember this case. Okay, so V line is basically square root of 3 V phase angle 30 degree. So VAB, remember, use the sequence ABC. VAB is equals to okay, wait. Okay, so square root 3, okay, VP angle 0 plus 30 degree, you get square root 3 VP angle 0 plus 30 degree. Okay, you get use plus VBC is equal to square root 3 VP, okay, angle negative 120 plus 30, okay, plus or minus. Okay, so this one is minus, not plus, sorry, this is minus. or plus. Okay, plus, sorry. Make sure you use the correct formula, plus. Okay, where is it? Okay, 90 degree. VP, okay, square root 3 VP, okay, negative 90 degree. Okay, and then VCA, CA is equal to square root 3 VP angle 120 plus 30 is square root 3 VP angle 150. Okay. Okay. Okay, you have the, okay, and then you have to find the current I. Okay, you get the phase, of course, when it comes to calculation, make sure you find the phase voltage at the load to get the current. So you already get the V phase as load. Okay, after that, then you can find the phase. Maybe I use a different color. Phase current. I phase. Remember, when you want to calculate the current, always start with the phase current and find the voltage, phase voltage at the load. At load. Okay, phase current at load, IP at load. So IAB is equals to VAB divided by Z. So you have a VAB here. Okay, VAB divided by Z, you get the answer. IBC is equals VBC divided by Z, you get the answer. ICA, this is a complex number. Make sure you calculate, your calculator is in the complex mode. Okay, this one is VCA. Okay, this one, okay, divided by Z. So you get the answer. Okay, now for the tricky part, the line voltage. So you can see here, line voltage here. This is IA, IB, and this one, maybe this location, IC. Okay. So you can see here, you already have IAB, IBC, and ICA. So you have already three days how you want to find this current. So of course you use the Kirchhoff current law. So IA is equals to, this is in, this is in, this is in, this is out. So IA is equals to IAB minus ICA. Okay, the trick is, okay, the trick is, if you can see here, if you want to find IA, it will start with A and end with A also. Okay, you can see here. Okay, if you want to find IA, it start with A and end with A. So you remember the positive sequence numbering, you just use that one. So IB is equals to, okay, so IB minus IB. So IAB, IBC, ICA, IAB. So something like this. This is the trick. Okay. So IC, remember IC minus IC. So recall back your sequence, positive sequence, IAB, IBC, ICA, IAB, IBC. So BC. Okay, that is how you find the equation. Okay, so this is a long way, long method. Okay, long method. So the original method. But if you want to find a shorter way, actually they have a shorter way. Okay, so basically from this, okay, this one is I line is equals to I phase. Okay. Sorry. Okay, we just take this one. Okay. So this is a simple one. IA is equals to IAB minus IBC. Okay, for a balanced load, this is the same. Okay, the phase shift is only 120 degree. Okay, this is for balance only. Okay, when it comes to simplification, the square root 3, that one is for balance load only. Okay, usually for balance load. Okay, okay, so IAB is maybe this one is I phase angle 0 degree minus I phase angle negative 120 degree. Negative 120 degree. So of course, when you do this, okay, I line is of course square root of 3 angle so you just use your calculator. Okay, I already forget already. So let me make it a calculator. Okay, I'll delete this. I phase 1 angle 0 degree minus 1 angle negative 120. Okay. So you get I line is equals to I phase square root 3. Okay. So 1 minus angle 30 degree. Okay, let me check the book first, textbooks. Okay. Okay, so you can see here IA is equals to this one. Okay. Oh, I use the diff. Oh, sorry, I use wrong formula. That's why I get the wrong answer. So this one is wrong, eh? Okay, let me delete this. Remember the formula, okay? A, B, B, C. So B, C, A. This one is positive, okay? Positive 120. Okay, this one is positive 120. This one is, so maybe I have to calculate again. Okay, this one is negative 30. So IPL is basically IP square root of 30, square root of 30, square root of 3, angle negative 30 degree. So be careful, eh? For the delta data connection, VL is equals to VP square root of 3 angle 30 degree. Okay, for current, you have to make sure it is negative. Okay, be careful with this. So this is only for balanced load. If not balanced, you have to use the original formula. Okay, we continue back with the derivation here. Okay, you get the phase current. Now you have to find the line current. Okay, line current for load or VL, IL, and or IL or IP for source. Okay, for the source, IL and IP is the same. Okay, because it is a delta star connection. Okay, so use the formula IL is equals to square root of 3 I phase, okay, angle 30 degree. So if you look here, So IA, okay, square root of 3 IP. Remember, this is balanced load. If this square root 3 IP is the same, and then the angle is, so for example here you have some angle. Don't forget the minus. Okay, theta P minus 30 degree. Okay, don't forget the theta P. Okay, theta PA, theta A, maybe theta AB. Okay, theta AB. Okay, theta is different for all phases, so make sure you differentiate it. So IB is equal to square root of 3 I phase angle theta BC minus 30 degree. Okay, and IC is equals to square root of 3 IP angle, okay, ABBC angle theta CA minus 30 degree. Okay, so you already solved everything. Okay, you get the voltage, you get the current for line and phase at load and source. Okay, so that is how you calculate. Okay, now how to draw it? Of course, for the phasor diagram, you can draw the current. Usually we look at the current for the star delta. Okay, depend on the question, they will show you. Okay, for this case, assume, okay, because we don't have any calculation, we don't know yet. Okay, I just show you in the textbook. You can see here the line current is 30 degree lower than the phase current. Okay, this is the example. Okay. So again, the book is broken. Okay, let me open it back. Okay, see, this is the difference. Make sure you know which one is line current. Okay, the line current is IA, IB, IC. Okay, and the phase current is IA, IB, IC. Okay, IAB, IBC, ICA. This is the phase current. Okay, so now this is example here. A balanced ABC sequence Y connected source, okay, has this load and delta load is per phase. Okay, calculate the phase and line current. So you just use the method I showed you before. Okay, so let me adjust this one so I clear this. Okay, if they ask you to draw, you draw it. If you can imagine it, I think not yet, because you still new at this. So I suggest you draw it and label it properly, because you can see it easily. Okay, so of course you have a Y connected source. Draw this. Okay, and then you label it. Okay, A, B, C, A, B, C. Remember, A is internally and C is the outside. Okay, Z, Z, Z. So of course you have to label everything. This one is VAB, not VAB, VAN. This is neutral. Okay, delete this first. VAN, VBN, VCN. Okay, of course the arrow is from negative side to positive side. Okay. Okay, and then you have to label the current IA. This one is okay. This one is wrong. Okay, this one is B. Inside is B, outside is C. Okay, and then this one is IB. This one is IC. And then you label this one VAB, VBC, VCA. And then you label the current here. Of course, positive sequence I A to B, I B to C, and then you have I C to A. Okay, positive sequence. Always follow the sequence. Okay, if you don't know how to draw this, you cannot get the answer. Okay, make sure you label it properly. Okay, after you already label it, I suggest you draw it. Okay, even if the question don't ask you, I suggest you label it because you can easily see the location. So of course, the step is you have to calculate the V phase at source. Okay, V phase at source is 100 angle 10. Okay. VAN is 110. Oh, 110. Okay, VBN, remember minus 120 degree. Okay, 100 angle 110 degree negative, and then VCN. Okay, 100. Okay, angle is 240, 120, 130 degree. So make sure you know how to do this. Okay, minus 120, and then this one minus 240. Okay. So then you have to calculate the V phase, V line at source that equals to V phase and V line at load. Okay. So just use the formula because this is a balanced load. Okay. Balanced load, balanced source. Okay. So V line is equals to square root of 3 V phase angle 30 degree. Okay. So current negative 30, voltage is positive 30. So VL is equals to VP 130 square root 3 multiplied by 100, 172, 72.73.21. Angle is, of course, this one is V line is VAB. Okay, VAB is equals to 10. Okay, you have to use the AN. Maybe I show you at the bottom here. Okay, VAB equals to square root 3 VP. Okay, angle, you take this angle, the first angle, theta AN plus 30. Okay, make sure you have A, start with A. Okay. So square root 3 multiplied by 100, you get 173.21 angle 40 degree. Okay, and then VBC is equals to square root 3 VP, get theta B, okay, B and plus 30. So you get 173.21 angle negative 130, negative 80 degree. And then VCA is equals to 173.21 angle. Okay, 130 plus 30, you get 173.21 angle 160 degree. So you have this answer. And then they ask you to calculate the phase and line current. Then you can get the phase and line current. Okay. So now, maybe I make it larger. So phase current. Okay, when you want to calculate phase current, I phase, make sure you have the phase voltage, this one phase voltage at the load. Okay, phase voltage at the load and the load itself. Okay, so IP is equals to VP divided by Z. So IP, I phase IAB, okay, VBAB divided by Z equals to, so IAB is this one. So 173.21 angle 40 divided by, look back the textbook, it's for per phase, okay? 8 plus J4, okay? You get, so use the calculator, 173.21 angle 40 divided by open bracket 8 plus 4i. Okay, use a rectangular form, or phasor form, I forget the name. Okay, 19.36 or 37 angle 13.43. 13.43. Okay, ampere. So you get IAB, IBC is, you get VBC divided by Z, 173.21 angle, this one negative 80 degree divided by 8 plus J4. So 19.37. Okay, the current always the same because this is a balanced load. Only the angle changes. Okay, this one, 8. Okay, negative 106.57. Sorry, my PC hang. 57 ampere, and then ICA is equal to VBC, VCA divided by Z, 173.21 angle 160 degree divided by 8 plus J40. So you get 19.37 angle. Okay, let me check with the calculator. Oh, and sorry, my calculator problem again. Okay, now 173.21 160 divided by open bracket D plus 4i. Okay, 133.43 ampere. So you get the phase voltage and now the line current IL. So IL is equals to square root of 3 I phase, okay, angle negative 30 degree. So IA is equals to square root 3 19.37 divided by 19.37. Okay, or we use symbol. Okay, multiply 19.37 angle. Okay, you have to take the first one. Okay, theta AB. Okay, remember, if you want to find the A1, you have to look at the first one is A. Okay. IAB minus 30. So 19.37 multiplied by square root 3, you get 33.55. The angle is 13.43 minus 30, you get negative 15.5, 16.57. IB is 33.55. Because this is balanced load, just copy it back. So theta BC minus 30 degree. Okay, don't forget the bracket. Okay, this one IBC, this one theta BC, negative 106.57 minus 30, angle negative 136.57. Okay, and then you have to finish all. IC is equal to 33.55, angle theta CA, remember IC theta C minus 30 degree, 33.55. Okay, 132.43 minus 30, 102.43. Okay, one trick that you can do is you compare this. Okay, for balance load, always 120 degree apart. If not 120 degree apart, for balance load only, balance load, okay, means that there is something wrong with your calculation. So you already answered the question. So that's it for today. Okay. So next week we will continue with delta connection. Okay. So see you again.